Okay, my apologies. I just skipped over this section called equivalent couples. Equivalent couple is just exactly what it says. Look at this diagram here. If you've got, say, a moment that is due to a couple, then you can have other systems that give you the identical moment, the identical couple moment, but you can have different couples. For example, you can have f and minus f applied there. Instead of there on those top corners, you can apply them on the bottom corners. They can give you the same couple moment. Or you can have forces applied in a perpendicular distance in this case, and it will still give you this rotational effect. Or you can have those same forces, sorry, that's not the same forces. You can apply two forces in a narrower distance, but with an increased magnitude, and it'll give you the same couple moment. So this is the idea of equivalent couples. Okay, and let's go and do an example. Alright, so here we have a rigid structural member subjected to a couple consisting of two 100 Newton forces, 100 Newton, 100 Newton. It's a couple, equal, opposite, not collinear, separated by a distance of 100 what? Meters? No, 100 millimeters. Okay. Alright, 0.1 meters. So what is the moment due to that couple? Straightforward. It's 100 times 0.1 gives you 10 Newton meter. So what we want to do is we want to say no, we don't want to apply these forces here. We want to apply forces here rather, but we want the same moment, the same couple moment. So what do we need to do? So we want to apply P and minus P at a specific angle, and P is given as 400 Newton. Well, we want equivalent couples. We want equivalent moments, right? So let's calculate this moment. Let's look at this from the top. We've got the 400 there. That's the one. There's the 400 with the angle, and we've got the 400 with that angle there as well. And now if you break it up and you use Varignon's theorem again, you can see if you break it up into that component and that component, this component is 400 cos theta, and that component is also 400 cos theta, and the vertical components will just cancel, right? So this moment is then 400 cos theta times 0.04, okay? And the unknown is theta, and then we need to equate. We equate this couple to that couple. So 10 Newton meter is equal to that, and we can solve for theta. Alright, so these are equivalent couples. Equivalent couples. Meaning the forces that I apply there are 400 at that angle gives me the same couple moment as we would have if we applied it there.